Hello, CP Finitians, and welcome to a new chapter on 2.1, solving linear equations. Okay, so like I said, a lot of this class is what we used to do in Algebra 1 and 2, and it's back. So today, solving system linear equations algebraically. First things you need to remember, we have a few methods. We're going to look at substitution and elimination today. First example, right on into it. Okay, substitution, the key thing with substitution is you want to have one variable solved for in order to substitute it into another. So we actually have a little challenging question to begin with here because we don't have any variables solved for. So we want to solve for a variable. Make it a simple variable, something with a coefficient of 1. So we're going to solve for this x. I like to label my equations. Get in the habit of doing that if you've forgotten. And we are going to then solve circle for x. To do that, that just means we would add 7y over, bada bing, bada boom, and we have x is equal to 7y minus 30. That is our new and improved x. With that x, I can then substitute it boop, 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 into the red equation. Okay, that's the whole idea of the elimination method. So you would have 3 times the quantity 7y minus 30. Okay, I like to always put my substitution in parentheses in case you have to distribute a negative. Plus 2y is equal to 2. Okay, distribute the 3, 21y minus 90 plus 2y equals 2. Here we go. Add 90 over to each side. Boo, boo, boo. 92 is equal to 21, and 2 is 23y. We're going to divide by 23. Divide by 23. 92 divided by 23. Hey, that's 4. I had no idea. Y is equal to 4. When you substitute y back in, because remember you want to get x and y, we need 2 different variables. So solve for x first, I suppose. You can then substitute it into either equation, triangle or circle, or even the one you made. I'm actually going to put it right back in the one we made. That way we just know x is equal to 7 times 4 minus 30, and x is equal to 28 minus 30. X is equal to negative 2. Boom. Negative 2, comma 4 is how you should properly write your answer. X, comma, y. Okay, easy example for that one there. Solve for, again, the coefficient that has a 1, if so. The next example, a little more challenging. What? And I would like you to do substitution. Okay, so you should be comfortable using different mathematical skills by now. Say we want to solve for y. Let's solve this one for y in the first equation, and you can do all these differently. It's no big deal. That means we move x over, so 1/2 y is equal to 2x, negative 2x. And we just want it to be positive y, so we can multiply then both sides by the reciprocal, and we then know that y is equal to negative 4x. Okay, so there is our substitute. We found our substitute. With that substitute, we can go ahead and put that then into the second equation. Okay, so now we would have 3 times x minus 4 times the quantity, negative 4x, equals negative 19 over 2. Okay, 3x plus 16x equals negative 19 over 2. 19x equals negative 19 over 2. Divide each side by 19. Be careful if you do this in your calculator. Negative 19 halves divided by 19. And you should just get 1/2. The 19s would cancel out. So x equals -1/2. Okay, substitute that back in to find y. Y is equal to -4 times -1/2. That is due to this equation. And y is equal to 4/2, or 2. Okay, you guys are heading into college. Some of you, either way, you are able to handle decimals and fractions by now. I hope you have calculators, so expect to see some fractions, not a lot, in your answers. Okay, that's the substitution method. Elimination method was the next one, and you should be comfortable with both, because when we get into solving systems with 3 variables, you'll need to know them. So example, this time the goal is to have opposite coefficients of a variable. So y in triangle is -1, and y in circle has a +1. So they're already set up to eliminate. If you remember, okay, if that is the case, we can eliminate, and that just means -y, +y cancel out to 0y. X and -3x is -2x. And then 3 and 1, don't forget to add the last column. A lot of students tend to do that, is 4. Okay, so really you just have -2x equals 4, divide by -2, divide by -2, bada bing, bada boom, x equals -2. Pop that back into the either equation. We'll add 2 over. -y is equal to 5, which means +y is equal to -5. Dividing each side, -1, -2, -5, boom, boom, answer. Okay? Example next to it. Sometimes, remember, you might have to set up for elimination. So you might have to scale or multiply an equation first, or both. Okay? Triangle, circle. I would say the goal here could be to eliminate y. All right, you could also eliminate x. Let me just show you how you can go about eliminating x. Okay, so I know that y would be easier, but I just want to show you, if you have to multiply both, we can certainly multiply triangle by -5. Okay, that makes triangle -10x plus 5y equals -25. And then circle, you can multiply by +2. Okay, so you can kind of switch around the variables. You can eliminate any variable you would like. Just make sure that you do proper mathematical operations. So that's a 2, not a 20. So that's the new circle. Again, the key, make sure they're opposites. So we have 0x, that's what we want. 9y is equal to -9, -25 plus 16. Yep, indeed. Y then is equal to -1. Pop that back into any equation, one of your modified ones or one of the originals. 2 times x minus -1 equals 5. 2x plus 1 equals 5. See what I did there? I put it in negative, so I distribute that. -1, -1, 4 equals 2x. X equals 2. Done. 2, -1. Bada bing, bada boom. All right. Last 2 examples I would like to show you. Inconsistent systems of a linear equation. Inconsistent is just a fun way to say there's no solutions. Okay? It's like we're moving up in the world. This is a more mathematically speaking term. Inconsistent. No solution. Inconsistent. Yes. Okay? Why that happens is if we were to solve this one, okay, use good old elimination method, just going to multiply everything by 2. That makes it -2x plus 2y is equal to -14. Okay, the x's cancel, The y's cancel. What? And on the other side, we have negative 24. 22. What are you doing, Dvorsky? Negative 22. And notice we have 0 is equal to negative 22. Okay? That is never true. Okay? If you have anything like this here, if you have a non-true statement, okay, non-true is no solutions, which means it's an inconsistent system. Okay, you should, again, if you get, when you do the homework, things like that, label things inconsistent if they have no solutions. Okay, the only other example then is just an example of a dependent system. Okay, and that's just a new way to say infinite solutions, or everything works. Okay, if you go about using elimination on this, so you multiply the top equation, call it triangle, by 3, you have 6x plus 3y equals 12. Here, not only do the x's cancel and the y's cancel, but we're also equal to 0. So now we have 0 equals 0. Okay, and in that case, we have infinite solutions. In finite math. That's why it's here. Just kidding. Okay, 0 equals 0, infinite solutions. You can also say, of course, dependent. Okay, so if you get a true statement, you might actually end up with like 5 equals 5, 6 equals 6, negative 3 equals negative 3. All of those are true, so dependent for that. Okay, so crash course reminding you how to solve using elimination and substitution. You need to be comfortable with both. Your homework questions ask you to do both. Okay, so thanks for doing those. Definitely practice these skills, and that's all, guys. Awesome.